Hello students, in this class we will learn application of arithmetic progression. Before learning the application of arithmetic progression, we will learn some special series, and then we will learn the how we can apply arithmetic progression in some problem. Okay, so let us study about some special series. If there is a series in the form one square plus two square plus three square plus four square plus continuing plus n square, then how we can find the sum of this series. Okay, so here our series is given, which is in the form 1 square plus 2 square plus 3 square plus continuing plus n square. And if we want to find the sum of this series, then what will be the way? If we follow this series, this is not an AP, because 1 square will give 1, 2 square will give 4, 3 square will give 9, 4 square will give 16. So these values, that is 1, 4, 9, 16, 9, 16 plus continuing, are not in AP. But if we follow these terms, that means 1 square, 2 square, 3 square, 4 square, these terms are the square of some numbers. Those numbers are in AP. That means 1, 2, 3, 4, these are in AP. But when we find their squares, they are not in AP. Okay. Now, if we want to find the sum of this series, then we have to follow some procedure. Type 1. Solution. P plus 1 whole cube minus P cube will give P cube plus 3P squared plus 3P plus 1 minus P cube. That means it is like A plus B whole cube. Already we know what is the formula or what is the identity expression of A plus B whole cube. That is A cube plus 3A square B plus 3AB square plus B cube. So by following this identity, we can express P plus 1 whole cube, and after expressing we get this. Cancelling this P cube, we get P plus 1 whole cube minus P cube equals to 3P squared plus 3P plus 1. Okay. So this is also an identity. Putting P equals to 1, 2, 3, continuing up to n. In the above relation, we get when p is 1, then 1 plus 1 will give 2. So 2 cube minus 1 cube is equals to 3 into 1 square plus 3 into 1 plus 1. When p is 2, then this will give 2 plus 1, that is 3. 3 cube minus 2 cube equals to 3 into 2 square plus 3 into 2 plus 1. When we put p equals to 3, then p plus 1 will give 4. So this is 4 cube minus 3 cube equals to 3 into 3 square plus 3 into 3 plus 1. Continuing, when we put p equals to n, then this will give n plus 1 whole cube minus n cube equals to 3 into n square plus 3 into n plus 1. Adding, we get, now if we follow this addition, then these 2 cube and these 2 cube will cancel out. These 3 cube and these 3 cube will cancel out. That is why finally the remaining term will be n plus 1 whole cube and minus 1 cube. Okay, and all the other terms will cancelled out like this way. If we follow the right hand side value, then this is 3 into 1 square plus 3 into 2 square plus 3 into 3 square plus continuing plus 3 into n square. Now if we take 3 as the common factor, then this will be 3 into 1 square plus 2 square plus 3 square plus continuing plus n square. If we follow this thing, this is 3 into 1 plus 3 into 2 plus 3 into 3 plus continuing plus 3 into n. There is also 3 as the common factor. If we take that 3 as the common factor, then this will be 3 into 1 plus 2 plus 3 plus continuing plus n. And this last term, if we follow these last terms, then there is only 1. And this 1 will be added up to n times because we put p from 1 to n. That is why last of all we can write 1 plus 1 plus 1 plus 1 plus continuing up to n. This will give n plus 1 whole cube minus 1 equals to 3 into 1 square plus 2 square plus 3 square plus continuing plus n square plus 3 into, this is an AP, 1 plus 2 plus 3 plus continuing plus n. Summation of this will give n into n by 2 into first term plus last term by following the formula of summation of AP. And when we add 1 up to n times, then this will give n, because 1 plus 1 up to n times will give n. Now, if we let s of n equals to 1 square plus 2 square plus 3 square plus continuing plus n square, then we can replace this by Sn. 3n by 2 into n plus 1 plus n. N plus 1 whole cube. This is plus n. When we bring this in the left hand side, then this will be minus n. So minus n minus 1. And this is minus of minus 3n by 2 into n plus 1. And in the RHS, there will be only thrice of Sn. Okay. Now, we can write this thing in this way. That is, this equals to thrice of Sn means thrice of Sn is equals to this. That is why we can write thrice of Sn equals to n plus 1 whole cube minus of, from these two terms we can taking out minus 1 as the common factor. Then this will be minus 1 into n plus 1, and this is minus 3n by 2 into n plus 1. Okay. Now, if we follow these terms, then n plus 1 is the common factor. This implies thrice of Sn is equals to n plus 1 whole into n plus 1 whole square minus 1 minus 3n by 2. After taking out n plus 1 as the common factor from these three terms, we will get n plus 1 whole into n plus 1 whole square minus 1 minus 3n by 2. This implies thrice of Sn equals to n plus 1 whole into, now if we find the LCM of these denominators, nothing is in the denominator means 1 is in the denominator. Then the LCM of 1, 1 and 2 is 2. That is why we can write 2 as the LCM. And after finding addition and subtraction at a time, we will get 2 into n plus 1 whole square minus 2 minus 3n. Okay. After doing addition and subtraction at a time, we get 2 into n plus 1 whole square minus 2 minus 3n whole divided by 2. This implies thrice of Sn equals to n plus 1. We can bring this 2 upon this n plus 1 as denominator. N square plus 2n plus 1. Like a plus b whole square, we can break n plus 1 whole square minus 3n minus 2 after arranging. This will give thrice of Sn equals to n plus 1 whole divided by 2 into 2n square plus 4n plus 2 minus 3n minus 2. We can cancel these 2. This implies thrice of Sn equals to n plus 1 whole divided by 2 into 2n square plus n. This plus 4n and this minus 3n will give plus n. Thrice of Sn equals to n plus 1 whole divided by 2 into, now from these two terms 2n square plus n is the common factor. So if we can take n as the common factor, then the rest of the term will be 2n plus 1. Okay, so finally we can write s of n equals to these three. When goes in the right hand side, then this will be multiplied with these two. That is why we can write n into n plus 1 into 2n plus 1 whole divided by 6. Okay, so thus last of all we can write 1 square plus 2 square plus 3 square plus continuing up to n square is equals to n into n plus 1 into 2n plus 1 whole divided by 6. Okay, so this is the way by which we can find the sum of this series, that is 1 square plus 3 square plus 4 square plus continuing plus n square, where the terms are not in AP. But if we follow their squares, then the terms then the numbers whose squares are the required terms are in AP. Okay, and by following this procedure, we find the sum as, that is 1 square plus 2 square plus 3 square plus continuing plus n square is equals to n into n plus 1 whole into 2n plus 1 whole divided by 6. Okay. In type 2, here we have to find the sum of the series one cube plus 2 cube plus 3 cube plus continuing plus n cube. Okay, so same as previous, if we follow each terms of this series, then the terms are not in AP, because 1 cube will give 1, 2 cube will give 8, 3 cube will give 27 plus continue. So these terms are not in AP, but these terms are the cube of some numbers, they are in AP. Okay, like 1, 2, 3, these are in AP, but when we break these cubes, then they will not form an AP. So this is a special series. So how we can find the sum of this special series? Then let us study about the procedure of finding the sum. Solution. P plus 1 whole to the power 4 minus p to the power 4. We can break p plus 1 whole to the power 4 in this way. P plus 1 whole square whole to the power 2. And after breaking this, by the way, a plus b whole square, we will get p square plus 2p plus 1 whole square. And then it is like a plus b plus c whole square. This is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. And finally we get p to the power 4 plus 4p cube plus 6p squared plus 4p plus 1 by following a plus b whole square equals to a square plus 2ab plus b square, and then a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, so by following these identities, we can express p plus 1 whole to the power 4 as p plus 1 whole square whole to the power 2. Then this will give p square plus 2p plus 1 by following this identity. Then by following this a plus b plus c whole square identity, we can express this in this way. And finally, we get p to the power 4 plus 4p cube plus 6p square plus 4p plus 1. P to the power 4 plus 4p cube plus 6p squared plus 4p plus 1 and minus p to the power. Cancelling this p to the power 4, we will get p plus 1 whole to the power 4 minus p to the power 4 is equals to 4p cube plus 6p squared plus 4p plus 1. Okay. Now, putting p equals to 1, 2, 3 continuing up to n in the above relation, we get when p is 1, then 1 plus 1 will give 2. 2 to the power 4 minus 1 to the power 4 is equals to 4 into 1 cube plus 6 into 1 square plus 4 into 1 plus 1. When we put p equals to 2, then this will give 2 plus 1, that is 3. 3 to the power 4 minus 2 to the power 4 equals to 4 into 2 cube plus 6 into 2 square plus 4 into 2 plus 1. If we put p equals to 3, then this will give 3 plus 1, that is 4 to the power 4 minus 3 to the power 4 equals to 4 into 3 cube plus 6 into 3 square plus 4 into 3 plus 1. Continuing, when we put p equals to n, then this will give n plus 1 whole to the power 4 minus n to the power 4 equals to 4 into n cube plus 6 into n square plus 4 into n plus 1. Okay. After putting p equals to 1, 2, 3 continuing up to n in this relation, we get 2 to the power 4 minus 1 equals to 4 into 1 cube plus 6 into 1 square plus 4 into 1 plus 1. Similarly, putting p equals to 2, 3 up to n, we get this. Adding all these things, we get, when we add these left hand side values, then these we can cancel these and these, then these and these, and by continuing this addition, the rest of the term will be n plus 1 whole to the power 4 and minus 1 to the power 4. And in the right hand side, this will give a particular form, that is 4 into 1 cube plus 4 into 2 cube plus 4 into 3 cube plus continuing plus 4 into n cube. If we take 4 as the common factor, then this will give 4 into 1 cube plus 2 cube plus 3 cube plus continuing plus n cube. This will give, after taking 6 as the common factor from these terms, this will give 6 into 1 square plus 2 square plus 3 square plus continuing plus n square. If we follow these terms, then 4 is the common factor, and after taking 4 as the common factor, we will get 4 into 1 plus 2 plus 3 plus continuing plus n. And if we add these ones, then there are n numbers of ones. That is why we can write 1 plus 1 plus 1 plus continuing up to n. This will give n plus 1 whole to the power 4 minus 1 is equals to 4 into now if we let s of n equals to 1 cube plus 2 cube plus 3 cube plus continuing plus n cube, then we can replace this by Sn 6 into this. In the previous type, already we know the sum of this series. This is equals to n into n plus 1 into 2n plus 1 whole divided by 6. Okay, that is why we can replace this sum by this value. This is an AP where first term is 1, common difference is 1, last term is n, and total number of term is also n. So this sum is equals to n into n plus 1 whole divided by 2. And after adding 1 up to n times, we get n. We can cancel this. 2 2s are 4, 6, 6. This will give n plus 1 whole to the power 4 minus 1 equals to 4 into Sn plus n into n plus 1 whole into 2n plus 1 plus 2 into n into n plus 1 plus n. N plus 1 whole to the power 4. If we bring all these terms in the left hand side, then this will be n plus 1 whole to the power 4 minus n minus 1. This will be minus of n into n plus 1 into 2n plus 1. And this will be minus of 2n into n plus 1. And in the right hand side, there will be only 4 times of s of n. So n plus 1 whole to the power 4. If we take minus 1 as a common factor from these 2, then this will be minus 1 into n plus 1 minus n into n plus 1 into 2n plus 1 minus 2n into n plus 1 equals to 4 times of Sn. Now from this whole thing, if we take first of all, from these two terms we will take n plus 1 as the common factor, and from this last two term we will take n plus 1 as the common factor. This will give n plus 1 whole into n plus 1 whole cube minus 1. And from this last two term, if we take n into n plus 1 as the common factor, then this will be minus n into n plus 1. And this whole into 2n plus 1 minus 2n equals to 4 times of S of n. From this first two term, we take n plus 1 as the common factor, and after taking n plus 1 as the common factor, the rest of the term becomes n plus 1 whole cube minus 1. And from this last two term, if we take minus of n into n plus 1 as the common factor, then the rest of the term becomes 2n plus 1 minus, plus 2. Okay. This will give n in n plus 1 whole into. We can break this by following a plus b whole cube, n cube plus 3n square plus 3n minus 1 minus n into n plus 1 into 2n plus 1 plus 2 equals to 4 times of S of n. We can cancel this plus 1 minus 1, and this will give n plus 1 whole into n cube plus 3n square plus 3n minus n into n plus 1 into 2n plus 3 equals to 4 times of S of n. This will give n plus 1. From these three terms, we can take n as the common factor. So, n into n square plus 3n plus 3 minus of n into n plus 1 into 2n plus 3 equals to 4 Sn. Then this is the term and this is another term. From these two terms, n into n plus 1 is the common factor. After taking n into n plus 1 as the common factor, the rest of the term becomes n square plus 3n plus 3 minus of 2n plus 3. This equals to 4 times of S of n. So, n into n plus 1 is whole into n square plus 3n plus 3 minus 2n minus 3 is equals to 4 times of S of n. We can cancel these 3 plus 3 minus 3. Then we can write n into n plus 1, and from this n square plus 3n minus 2n will give plus n, n square plus n equals to 4 times of s of n. Then we get n into n plus 1. From these two, we can take n as the common factor, and after taking n as the common factor, this will give n into n plus 1 equals to 4 times of Sn. So this will give n into n plus 1. We can bring this 4 here. So 4. 2 square is 4. That is why we can write this as n into n plus 1 by 2 whole square. Okay. These two will give n into n plus 1 whole square, and when this 4 comes in the left hand side, then this will be divided, this will be in divide form. So 4 means 2 square, that is why as a whole we can write n into n plus 1 whole divided by 2 whole square. So thus we get this series. We get the sum of this series as 1 cube plus 2 cube plus 3 cube plus continuing plus n cube is equals to n into n plus 1 whole divided by 2 whole square. Okay. So these are some special series. Okay. Now with the application of this series, how we can solve a problem. Okay. So let us study about a problem where we can use these kind of series. So we learn this special series. That means the how we can find the sum of the special series, and after learning the procedure we get this value. That means sum of 1 square plus 2 square plus 3 square plus continuing up to n square is n into n plus 1 whole into 2n plus 1 whole divided by 6, and 1 cube plus 2 cube plus 3 cube plus continuing plus up n cube is equals to n into n plus 1 whole divided by 2 whole square. Okay. Now we can also write this this sum by some notation. Okay. We can also write 1 square plus 2 square plus 3 square plus continuing up plus n square by this way. Okay. So this is known as summational representation, or this is known as summational representation by some notation. Where this represents symbol of sum. Okay, and this is lower limit. Lower limit means here we express this 1 square plus 2 square plus 3 square plus continuing plus n square by this way. That is summation of p equals to 1 to n of p on p square. Okay, that means here we choose a variable as p, and whose value uh, starts from 1 and continues up to n. Okay, so this notation, this is known as sigma, and this represents symbol of sum. Okay, so this is the summational representation of some series, or we can say this is a shorter representation of some sum, where we can express the general term by this way. Okay, so if we put p equals to 1, then this will give 1 square. If we put p equals to 2, then this will give 2 square. If we put p equals to 3, then this will give 3 square. Okay, so and this symbol represents sum. So after adding this whole thing up to n square, we get this. So this is the symbolic representation. Similarly, we can express 1 cube plus 2 cube plus 3 cube plus continuing plus n cube by this way. Summation of t cube, where t is a variable whose value starts from 1 and continues up to n. Okay. So these are the symbolic representation, or we can say the shorter representation of sum. Here we choose a problem, and in this problem the terms are in addition form. We have to find the sum of this series up to n square. Okay, so this if we follow this term, then there is no specific identification. That means the terms are not directly in this form or in this form, or these terms are not in a direct AP. Okay, so that is why there will be some trick by which we can find the sum of this series. If we follow these terms, then the first terms are 3, first terms are 3, 4, 5, continuing. That means these first terms follows an AP, 3, 4, 5, continuing. Okay, and the second terms, they are 1 square, 2 square, 3 square. They are not in direct AP, but these terms are the square of some numbers. They are in AP. Okay. The pth term of the given series equals to 3 plus 4 plus 5 plus continuing up to p, sorry, the pth term of the given series will be the pth term of this AP. Pth term of the series 3, 4, 5 continue. And for the second part, this will be pth term of the series 1, 2, 3 continue, and then the square. Okay. So, if we want to find any term of this series, then we have to find or we have to follow this series individually. That is why the pth term of the given series is equals to pth term of the series 3, 4, 5 continuing into pth term of the series 1, 2, 3 continuing, and then the square of this. This is an AP. Its first term is 3 and common difference is 1. Pth term is A plus P minus 1 whole into D. Here A1 equals to 3, D equals to 4 minus 3 equals to 1. And A of P equals to A1 plus P minus 1 whole into D. By following this formula, we can write this. And this will be, if we follow this series, then its pth term will be P. That is why we can write P square. This will give 3 plus P minus 1 whole into P square. Thus, P plus 2 whole into P square will give P cube plus 2P square. Okay. Pth term of the given series, we can say A of P. So, putting P equals to 1, 2, 3 continuing up to n, because we have to find the sum of the series up to n terms. That is why we have to put the value of P from 1 to n. Putting P equals to 1, 2, 3 up to, continuing up to n in A of P equals to P cube plus 2P square, we get A1 equals to 1 cube plus 2 into 1 square. A2 equals to 2 cube plus 2 into 2 square. A3 equals to 3 cube plus 2 into 3 square. Continuing, A of n equals to n cube plus 2 into n square. Adding, we get A1 plus A2 plus A3 plus continuing plus A of n equals to 1 cube plus 2 cube plus 3 cube plus continuing plus n cube. And from these last two terms, last terms, If we take 2 as the common factor, then this will be plus 2 into 1 square plus 2 square plus 3 square plus continuing plus n square. Okay, sum of these terms, that is a1, a2, a3 up to n, will give the sum of this series. Now we can apply this formula. This is like a 1 cube plus 2 cube plus 3 cube plus n cube. Okay, that is why we can replace this by n into n plus 1 whole divided by 2 whole square. Then we can use this sum by this formula. That is why we can write plus 2 into n plus 1 whole into 2n plus 1 whole divided by 6. Cancelling this, we get so we get n into n plus 1 whole square by 4 plus n into n plus 1 whole into 2n plus 1 whole divided by 3. So, one cube a1 plus a2 plus a3 plus continuing plus an is equals to n square into n plus 1 whole square whole divided by 4 plus n into n plus 1 whole into 2n plus 1 whole divided by 3. Now we can find the LCM. LCM of 4 and 3 is 12. And after adding, we get 3 into n square whole into n plus 1 whole square plus 4 into n plus 1 whole into 2n plus 1. Now from these two terms, this and this, we can take n into n plus 1 as the common factor. So the rest of the term becomes 3n into n plus 1 plus 4 into 2n plus 1 whole divided by 12. Finally, we get n into n plus 1 into 3n square plus 3n plus 8n plus 11n three n square plus 3n plus 8n, that is plus 11n plus 4 whole divided by 12. So this is the way by which we can find the sum of this series. So if we follow this series, then we will get the first term follows an AP. Okay, that means 3, 4, 5. These are the first term of every terms and they follows an AP. That is why we write the first term as 3, 4, 5 continue. And if we follow the second terms, they are also following some special series. Okay, that is why we write these second terms as 1 square, 2 square, 3 square continuing. So to find the sum of this series, first of all, we have to find a certain number of term of that series. And that certain number of term, here we consider as the pth term. That is why we write pth term of the given series as a of p is equals to pth term of the series 3, 4, 5 continuing into pth term of the series 1, 2, 3, 4 this whole square, because these individual 1, 2, 3 forms an AP. That is why we write pth term of the series 1, 2, 3 whole square. Okay, and then we follow these terms, and after multiplying these general forms, we get AP. That means pth term of the series as p cube plus 2p square. Then putting p equals to 1, 2, 3 continuing up to n, we get a1, a2, a3 and continuing up to a. And adding these all terms, we get a1 plus a2 plus a3 plus continuing up to an. And then these additions follow this series. And then after putting the sum of the special series, we get this, and after simplifying, finally we get the sum of the series as n into n plus 1 whole into 3n square plus 11n plus 4 whole divided by 12. Okay, so this is the special case about the application of AP. Okay, in our next class we will learn about another special sequence and series, that is geometric progression. Okay.